Hi, everyone, and thanks for tuning in to the second episode of the Printed Circuit Podcast, where we'll discuss trends, challenges, opportunities across the printed circuit engineering industry. I'm your host, Steph Chavez, and as a refresher, I'm a senior product marketing manager with Siemens with 3 decades of experience as a printed circuit engineer and currently the chairman of the Printed Circuit Engineering Association. So joining me today is Richard Barnett, Chief Marketing Officer with SupplyFrame. Richard, thanks for joining and being here.
Oh, it's always a pleasure, Steph. Thanks for having me.
Awesome. Like I said, it's great to have you here. You know, on our last episode, I talked with Chad Jackson, who is Chief Analyst and CEO with Lifecycle Insights, about the new normal that we're living in now, especially with what's unfolding in the industry and how things are. It's just been totally chaotic, with the pandemic and geopolitical issues going on in the world. You know, I'd like to take a deeper dive into the topic and really focus on existing organizational infrastructure and why it's adding to the problem. You know, what is your take on that?
There's an interesting pattern you can look at most organizations that have design engineering teams that, create or design hardware that's a part of their products or services to their customers. And it really spans multiple industries. I mean, it's the same pattern and issue, even though it plays out slightly differently with companies that are early in their growth period and high-tech startups. There's to the very, 20, 50-year-old industrial equipment or aerospace and defense organizations stuff. What's interesting over the last few years is that we've seen it be very consistent, but it's a significant challenge and problem that essentially is really, sort of faced a significant turning point for many organizations where characteristically you would have these silos, these organizational silos that really haven't evolved that much in where we've seen massive digital transformation, oftentimes a lot more cross-functional integrated processes or collaboration inside the organization or across an ecosystem outside. We've seen this is an area that's been left behind. And what we mean by this is typically an organization that has an engineering team that has a set of engineering sort of competencies within that team. It often includes design engineering, component engineering specialists that are kind of a shared service across different programs or projects that are going on where they're reviewing obsolescence of critical parts and components, or they're making sure that there's compliance or governance around the AVL or the approved vendor list for key suppliers when those new design cycles are kicking off. And obviously it includes other functions, oftentimes within engineering as well. That includes test, quality assurance, other related activities, maybe design for manufacturing as well. But when we look at the kind of core electronic design components and the process of designing, selecting key components and building that into a design bill of material, what traditional organizations have given their engineering teams a high degree of autonomy to make those design decisions to achieve the top level goals for that product or that design. Oftentimes there's a reuse of maybe key components or design elements that were used in an earlier version or earlier generation of a PCB board design or another product. And sometimes that goes back, 2-3 years, right? Because these design or product life cycles can, depending on the industry, can be as short as 18 months, but can be as long as 3 to 5 years. That reuse, that kind of let's build on what we knew before, and then let's try to pick the best design to quality decisions, but let's just pay attention to the parametric information. Let's make sure that it's, built for design, that it has the appropriate attributes for that application, et cetera, has been totally fine and good enough. It's been a very stable set of what I call an authority domain around decision making. The challenge has been in this new market is that model that, kind of good enough, the good old days, right, of sort of making those design decisions and then pushing them forward in a typically a linear process where there may be a checkpoint review with component engineering, and then it's kind of thrown over the wall to sourcing procurement to either buy and select sort of the early volumes of maybe the early build quantities or the first test quantities all the way up through that, true new product introduction that's going to be on a path or a roadmap and a schedule for ramping to volume. All of that's occurring really to the right, if you will, of that core initial process. And there's not really been a lot of common feedback loops or collaboration. It's created a huge problem where organizations have been surprised and caught off guard by parts, components being designed in, which in this market reality over the last 2 to 3 years may be dead on arrival. There may be no available supply worldwide for that component, or the component that was used in an earlier design, just 18 months ago, particularly during the start of COVID. Now, that had a 6-week lead time now is up to 45 weeks, right? I mean, we've seen that all over the place around almost every commodity category. This isn't just your most expensive, most critical to design, say IC or custom ASIC or something. This is really across the board. I mean, including what we call popcorn parts. Your typically very low cost, typically assumed to be highly available passives, for example, like ceramic capacitors or transistors and diodes. The root of this is process, but it's also incentive management. These organizations, design teams, have been generally been held accountable to new design, new product or project being released on time to top level target design goals, but not necessarily on the commercial feasibility of that, either the ability to manufacture on time, the ability to ramp to volume on time, or the ability to hit revenue and margin goals, even though there's a plan and there's a notional target that's established, typically early on. It's not really the engineering team's full responsibility or accountability to hit those goals that are further downstream. The other real common issue is what I call the digital thread of intelligence around what's going on with those components, right? So oftentimes the information, traditionally the part component libraries of a CAD environment or an engineering shared environment for kind of a product life cycle management, where there's a repository of past bill of materials and design. A lot of that information has been static, updated infrequently, and only covers the parametric or technical details of that part or component. Traditionally, the big focus was on the years to end of life or the obsolescence status of those parts or components, particularly in industries that are building products or services that have a very long life cycle with the customer. And that's very true in industrial, very true in aerospace and defense, pretty true in automotive, right? 5 to 7 year kind of program life cycles, right? But what's been missing is the same intelligence extended into what's the supply market look like? What is the actual current and projected lead time? What is the current demand for those similar components? How popular are those engineering design decisions that a company might be making in a silo? How is it playing out in the broader ecosystem, the broader community of similar design engineers, that are working in similar application areas? All of this now is becoming incredibly important in order to design products and make decisions at the lowest cost of change, which is as early in the design process as possible, that have more intelligence, and that's that shared intelligence maybe that is connected or extended. So everyone's working off the same single source of truth. Everyone's making trade-off decisions that they're trying to balance design quality goals, feasibility of design, alternatives, maybe the cost of onboarding alternate suppliers, the overall cost of those components, and then the overall success of that product over its life cycle has now become the critical shared decision making that needs to happen. But in most organizations that we work with today are in the reason they have collapsed those silos, but not in a structured, coordinated, top-down led alignment, way. It is react, firefighting mode. It is emails. It's Excel spreadsheets with bombs. It's calling suppliers. It's getting a quote. It's scrambling to find out who found the latest on what last week on those 15 key components that we had on critical part shortage. And hey, can design, go back and redesign potentially either a sub portion of that overall design or even a complete product almost from scratch. I mean, a fundamental redesign cycle is now consuming anywhere between 10 to, we've seen up to 60% of an existing engineering team is completely cannibalized with just trying to redesign existing products that are already released to market in manufacturing so that they can feasibly just make more of it equivalent to meet customer demand or to meet it's the same product design requirements and just play catch up. And everyone across the board is just burned out. I mean, and so these conversations, this collaboration is happening in a highly constrained way, a lot of finger pointing going on. And the last element I would say that really shocks me is that at the C-level leadership, there is obviously an awareness of the problem, right? There is a significant eyes on the problem. But the idea of what is a better answer, what's a better approach, there's not clear consensus at most of the executive teams that we start bumping into. We talk to the CFO, we'll talk to a CEO, we'll talk to a general manager of a business unit, obviously talk to supply chain. Very different views. I feel like it's a bunch of the blind folks, touching the elephant, in the room. And it feels like the tusk, it feels like the tail, it feels like this big leg. That's where we need to anchor our focus. One of the design engineers at an aerospace and defense supplier was telling me that, the best response he's getting from his C-level teams, the last few months has been, well, what do you need? Do you just need more headcount? I'll approve more headcount for you to hire. And we were just laughing at that, going, throwing bodies at this problem is not the answer. So we're kind of in a crisis moment, but there's so much silver lining. There's so much, this is a crisis that if we take the right steps, not just these organizations will be more resilient, but their success in the market will be better. Their customers will benefit. And there's an ecosystem effect here too, where we're getting better intelligence, more collaboration, more agility built into the way we're going to market, that we're designing products, and we're thinking about collaborating all the way through its life cycle. And it really is exciting to me, but boy, the cost and the challenge and the pain that everyone's been going through is just, mind-numbingly painful to me.
You mentioned so much golden nuggets in the last 10 minutes of what you just shared with us. And I would tell you the first thing that jumps out at me is when I think about the infrastructure and how companies are organized, from my last 13 years or 12 years within the mil-aero, but in my decade of consulting and working, whether it's commercial, medical, military, aerospace, it's amazing how people stay in their swim lanes and their inherent walls built up. And the resistance to change is typically just what I see as like internal culture within a company. And that becomes the most difficult hurdle to overcome. When you talk about design for resilience, you're talking about bringing external content and knowledge to the point of design. The problem is that there are internal battles that go on where people, hey, that's my job or that's not my job. And so they stay in their silos. And the sad thing is that the way we've been producing in the past or functioning in the past is a just-in-time approach. Well, guess what? That does not work anymore. I shouldn't say it doesn't work, but you will not be able to sustain and survive if you maintain status quo. You have got to adapt and evolve with what we're seeing with the supply chain. Now we know, it's there, it's in our face, and we need to move on. And the companies that embrace this and adapt to it, they'll survive and be extremely successful. Those that don't will slowly fade away. It's sad. I've witnessed this firsthand. I refer to it as feeling the supply chain pain. And believe me, as a board layout designer, it's brutal. And I've seen it on projects, reiterations like you talked about, the spiderweb-like networks, the way our communication, whether it's stand-up meetings or it's emails or it's verbal communication, we have so many opportunities to be optimized and better. But the problem is that companies are not willing to change it on the fly because a customer is not willing to pay for you to design their widget and pay for you to optimize your process to make their widget. They just want their widget. That's the trade-off. That's the challenge. So how do companies change and adapt? They're going to have to find a way. And there are many companies are doing this and are killing it. When we talk about this linear approach, this is the other play that's an issue. And it's with our current process. These linear approaches, as we observe them, how many companies operate today? And, we're very complex. Can you expand on that even more? Especially when we talk about how we're functioning or lack of cohesive function and optimization.
Well, like I said a little bit earlier before, part of this requires a systems mindset, right? Where you're thinking about the digital, aspects and knowledge and intelligence that we can apply to the part component, to the PC board, to the product itself. And then thinking about, okay, how do we collaborate with intelligence, internally, right? So some of this is about extending the scope of the intelligence that we've already been investing significantly to empower engineers with more intelligence at their fingertips. So if they have a need for autonomy, or if there's a design cycle that's kicking off and they want to be empowered to look at all the trade-offs and considerations, part of the move is to empower them with the right intelligence around supply market conditions. They don't have to be an expert at every supplier. They don't have to be able to know all the supply market dynamics, but there's a bridge there, right, where you start introducing risk ranking, for example, or a view of red, yellow, green, even just as a huge start to simply try to filter out first level pass quality mindset around supply market feasibility, et cetera, because now that's becoming, it's additive. We're asking those teams to do more, but we can do this without breaking glass. We can empower those teams to operate the same way that they've done before, but with more intelligence, right? And you change the scope of what the outcomes they're trying to drive towards, right? And that becomes a new concept of how do we think about risk and risk of the product or risk trade-offs, right, in design cycles. So I think it starts there. It's about empowerment. It's about the same source of intelligence. But as soon as we step outside of that kind of core design engineering area, you're right. We need to be thinking about the new product introduction process in a different way. And the reason why I call the MPI process out is that many organizations will have at relative levels of maturity, fairly repeatable, somewhat formalized and maybe overly formalized bureaucratic approach, somewhat ad hoc in some cases. But generally, these MPI teams are really where there's an opportunity to build and extend a cross-functional decision making that's better than what most companies are doing. Because really, MPI stakeholders typically are cross-functional. You generally need to have the right representation of program or project management across engineering teams that then extends into release management into manufacturing. So you typically will have some form of manufacturing, supply chain or procurement representation, finance, and then even commercial teams, right? They're looking at and understanding, okay, we have an initial design, but let's iterate and make additional trade-offs, either for assurance of supply or for cost optimization, design for manufacturing, or just from a time to market perspective, because some of the ramp to volume limitations are one of the guiding most critical factors right now. And so many organizations, particularly in regulated industries, if you look at medical device, automotive, and mil-aero, have what I would call an MPI process that's on face highly formal, but based upon a very bureaucratic, procedural, checklist-based approach to ensure that there's documentation, that there's compliance, that that there's a review process that's meeting the kind of regulatory mindset, right? Of either to quality or to external regulation. And that takes many different forms, right? Whether it's FDA regulations, whether it's within mil-aero itself. We can build on that though. And it needs to look a lot less bureaucratic and checklist oriented and much more empowered around dynamic trade-off analysis so that you can iterate and sort of see what's the net change of the sum of all the changes that we're looking at making on an overall risk score, on the overall target costing model, on terms of accuracy, on even demand forecast changes, right? Incorporating those scenarios now more dynamically in, rather than just having that artificial one number that no one ever believes is going to be achieved, right? All of that needs to come in together. And I would argue it's the MPA process, which is the starting point. But then the other aspect of this is you want to look organizationally at where is the MPI process housed inside that organization. And companies that have a stronger center-led supply chain services organization are good holders of the flame, keepers of the flame, so to speak, of that MPI process. Sometimes organizations are a little bit more P&L focused, traditionally by a business unit function or maybe a manufacturing plant location, and it's harder to have it's engineering sort of coming into a different directly into manufacturing or contained within a business unit. And so it'll vary a little bit around how that organizational model needs to evolve. But generally speaking, it's about thinking, how do we drive more intelligent decision making? How do we improve the agility and speed of these decision making cycles? And how do we make sure it's more cross-functionally visible with all key stakeholders so that as market conditions change or as the evolution of the product evolves, everyone's aware and understands why decisions were made. And as the market conditions change, they can go back to a digital model of that product and those assumptions and make those changes very quickly and then realign to whatever they need to do, whether that's alternate part selection, whether that's bringing in alternate suppliers, it's choosing an alternate manufacturing location. That's really at the core. It's a digital enablement of a process that might be existing today, but needs to be super powered way beyond where it is today. We need to lean in on that aspect because the information, the technology, the intelligence is really all there. This is really about organizations, this is a leadership challenge, right? Change management challenge. This is about reapplying those capabilities in the right way. And you can start in different areas. It's not a big bang change, right? But you can start by empowering engineers, or you can start by empowering sourcing procurement teams to, work better. But we need to invest in this area. This is an area that's been left behind in almost every other digital transformation within the enterprise. We've had years of iterations and experience, almost 2 or 3 generations worth of thinking around redefining customer experience or redefining and thinking about global finance consolidation and managing in a dynamic market, treasury management, cash management. All of this is leapfrog, right? But we have not moved an inch in this area, in this zone, since the beginning of the first wave of digital transformation. And so there's no excuse for this. We have to lean in. We have to move.
I couldn't agree with more. As we're diving even deeper into how enterprises leverage operations today, we clearly see that the touch points of the external data source, not surprisingly, the external to the spiderweb-like network of operations that one, these touch points range from the part and pricing demand, parametric search of alternates, supplier ramp availability, part availability, and lead time, supplier geo risk, alternative supplies with regarding to popularity, financial health, and capacity. Then you have these touch points that are external to the enterprise that were initially dealt with downstream. We now got to move them upstream. And I think you commented that, basically by saying, we're shifting left. I mean, can you give me your insight as to the shift left or your thought on that as well?
We've heard shift left used in other contexts, but it's very relevant now because I think the idea here is that we need to have a systems mindset and we need to be thinking about root cause. We think about quality management, we think about root cause, remediation, and protective action, right? Same mindset here, right? But if you really think about it from a systems perspective, where does resilience, where is the lowest cost of change, and where does the potential risk of locking in risk occur in a product's life cycle? It starts with design engineering. And that's the whole point of shifting left. What we have to do there is not just process-wise shift left and just put more pressure on design engineers, which are already being overworked and burned out and under pressure, right? But we need to empower new information so that those design engineers feel like they're looking at the same trade-offs as early as possible. They're not flying blind. Because part of this is, you're going to get suboptimal decisions with very, very smart, team members in design engineering and component engineering even, if they just simply don't know what they don't know, right? So we got to start solving that problem. Take the blinders off, provide the right outside-in intelligence, like you just said. The other aspect of this is that we also need a concept that is moving into more of an awareness that the information that's actually needed to make these trade-off decisions does not exist inside the enterprise, right? And that's a really important paradigm shift. Most organizations still today think, well, if it's in my part component library, if it was on my approved vendor list, I mean, we have in our ERP system, the last PO for the cost that we had for that part. Aren't we good? Don't we know cost? Don't we know what's safe to select? Don't we know who our best, vendors are? The answer is no. One customer, I challenged them with this thought. I said, do you realize that 95% of the information that you have about your suppliers and your parts and components in your ERP system is inaccurate? That your MRP lead times are actually completely inaccurate? And they, came in and said, what do you mean? They would just think about it for a second. You have lead times that were set 3 years ago as your standard lead time for a part or component by a supplier. None of that is accurate today. That means all your enterprise systems that you've invested millions and millions of dollars or euros into over 20 to 30 years, they don't serve you here. And so if you start with that presumption, then change happens, and it happens pretty quickly. But the other dimension of this is this mindset of, if I'm only checking for obsolescence and the AVL, I'm good. And I would argue that it's table stakes. It's just table stakes. Like, that doesn't move you down, solving this problem at all anymore. It doesn't help you make any value-added decision. It will reduce some risk. You don't absolutely want to select a part or component that's obsolescence. But the default lead times, when we move into 45 weeks, 52 weeks, 60 weeks, that's exceeding the obsolescence risk of any available part or component that you're trying to protect. That's the issue that we need to solve for.
I agree. I can tell you most EEs, when they're selecting their parts at the point of design, are picking from a library that is a static library of information that was done whenever that part was released into the system. They have no idea of availability, price. All they know is it's a released part in the library system. I think you nailed, over the last 15, 20 minutes that you shared with us your thoughts, you've hit everything on the head. You've nailed it. And, now that we've established the problem, where it lies, which is in the process, we need to get to the solution. And, the solution is supply chain resilience. It's the capacity of a supply chain to persist, adapt, and transform in the face of change. This leads to the question, though, how can business manage risk and plan for a resilient future? That's what companies need to look internally and figure out for themselves what they need to do. I mean, you and I and many others, we are publicly addressing this, but ultimately, like we talked about, company leadership, they're the ones who got to implement the change, and they're the ones who got to do this. Because I know dang well that the engineers down in the trenches, They want to adapt and change, but they are locked in these swim lanes or in these inherent legacy processes that are not inherent, that were designed for resilience is not inherent to it. Richard, I can't thank you enough for joining us and being here today and sharing your amazing golden nuggets with us.
Thanks, Steph. This conversation, I think, is so absolutely critical. We're both very passionate about it, but I think we need to sing from the mountaintops a little bit because, there needs to be this active conversation. Every single customer we're talking to, it'll play out differently, but these insights and the guidance I think that we can provide and learn from, those that are leading the way are absolutely critical right now. So thank you so much for having me, and I look forward to the next opportunity to join the conversation.
Awesome. The pleasure's mine. I hope this discussion has been insightful and understanding how existing infrastructures puts you or your company at a disadvantage, where resilience is not built into the design process, while we adapt to move on to better supply chain resilience. So tune in next time for a deep dive into how knowledge enables supply chain resilience. Thank you, and I hope you continue to tune in and follow me on this Printed Circuit podcast.